All right, ladies and gentlemen, today we're going to be talking about lecture 1.7, electronegativity and atomic radius. We're going to get into our last subject for today and deal with our last two learning targets, so let's get right to it. The first two things you got to know, you have to understand that we're going to be dealing with atomic radius and ionization energy and explaining how they change as we move across the periodic table. We're also going to talk about one little twist called ionic radius, which is what happens to an atom when it becomes an ion, and does the radius shift, change, develop, increase, decrease? We'll talk. You ready? Let's start off for today with a little bit of review. You have to remember that we have in the center of our nucleus are positively charged protons. These positively charged protons, which you can find right in here, attract our negatively charged electrons, and they're pulled towards each other. Now, the closer they are to the nucleus, the electrons are to the nucleus, the more they feel the nucleus. Therefore, the tighter they're held. The further away they are, like the ones out here, the more they're shielded by the inner electrons, therefore making it harder for the nucleus to pull the electrons in and keep them held tight. Let's talk about some other implications for this. Today we're going to discuss electronegativity. Electronegativity is the measure of the ability of an atom to attract electrons. So let's imagine we have these little students, right? We have all these little students over here. I'm bringing all my students into class. Oh, hey teacher, what's going on? My backwards hat, I look pretty cool. Now, if I brought a student to the front of the room and said, which are you more attracted to? The Flamin' Hot Cheetos or the stick of lettuce? Which do you think they would say? My guess is you're gonna pick the Flamin' Hot Cheetos. The Flamin' Hot Cheetos have a much greater ability to attract students than lettuce does. In the same way, really strong elements are much more inclined to attract electrons than really weak elements. And we're going to talk about what it looks like right now. So electronegativity has the exact same trend as ionization energy. It increases as we move up and to the right. So as we go down a group, the electronegativity decreases. As we go across a period, the electronegativity increases. And remember, electronegativity is the ability to attract electrons, to pull them in. So at the top of the periodic table, we have all of our strong elements, the ones that attract very strongly, the hot Cheeto-like elements. At the bottom, we have the lettuce-like elements, the ones that don't attract quite as strongly. And in the other sense, on the left side of the periodic table, we have the lettuce elements that don't attract as strongly. On the right side, we have the hot Cheeto elements, which attract much more strongly. Now here's why this happens. As you move down on the periodic table, electrons become shielded, the outer electrons become shielded from the inner electrons, by the inner electrons, from the positively charged nucleus. So as we add more orbits, the electrons get further away and the nucleus has to reach through all these other electrons to try and pull this electron in. So therefore, as you move down the periodic table and elements get bigger, the electronegativity decreases because the nucleus doesn't have as great an ability to attract those electrons. As you move across a period, you see the same kind of effect as we did with ionization energy. The more protons in the middle means it's a stronger pulling force, which means it's going to pull them in closer, attract them more effectively, and make sure that no one can steal them. And this only happens within a specific period. So let's give a problem like this a shot. We want to order the elements from smallest to largest electronegativity. Oxygen, beryllium, lithium. I could look at my periodic table, and I just did. Let's say I just did. I would notice that on my periodic table, in the exact same period, I have oxygen over here. And then if I move all the way across the periodic table to the left, I have beryllium. And next to beryllium, I have lithium. Now, we know that electronegativity increases as we go up and to the right. Therefore, as we move up this way, they're going to get stronger. So the smallest electronegativity is going to be the one furthest to the left, in this case, lithium. Followed by beryllium. And finally, the strongest element, the one with the highest electronegativity, the one with the highest ability to attract electrons, oxygen. My main man, oxygen. I hope this made a little bit of sense. I want you guys to give this a try with two of these problems right here. Order the elements from the largest to smallest at electronegativity: chlorine, bromine, and fluorine. As well as order the elements from the smallest to largest electronegativity: silicon, aluminum, and sulfur. Give it a shot. Let me know how you do. And when you're done with that, go ahead and summarize what we've learned for the time being. Let's discuss atomic radius. The next thing, atomic radius, is the distance from the center of the nucleus, right here, to the furthest outside edge of the electron cloud, right there. That distance is known as atomic radius. And that's basically how big the atom is. Now, atomic radius gets a little funky, and I'll show you exactly why. Atomic radius trends work the exact opposite of the other ones. We saw the ionization energy increase as we move up and to the right. Electronegativity increases as we move up and to the right. But atomic radius increases as we move down and to the left. So it works in the exact opposite direction. The biggest elements are in the bottom left, and the smallest elements are in the top right. Why does it increase as you go down a group? Essentially what happens is that as you add more electrons to an element, as you add more shells, the element becomes bulkier. Essentially it looks like this. As you go down a group, you have one electron orbital at the top, maybe two in the next one. As you go down, you keep adding more electron orbitals, and more, and more, and more, and more. You get the picture. It gets bigger and bigger and bigger. As we get bigger and bigger and bigger, as we move down, the element gets bulkier and the radius becomes larger. As it gets bigger, it also gets weaker. Remember that as well. Now, as you move across a period, they get smaller because, as we discussed before, if you have your nucleus in the middle and you're putting your protons in there, as you move across the periodic table, you add more and more protons to the center. As you add more protons to the center, the element gets stronger, the nucleus gets stronger, and it starts to pull in the electron orbitals a little bit closer, because now it's dealing with the same distance but more pulling power. So it's the same distance away from all these electrons. We keep adding more, it still stays the same distance, but now there's more force in the nucleus. Therefore, it's going to pull this ring in a little bit, just a tiny bit, make it a little bit smaller every time. So as we go across, atoms get slowly smaller and smaller and smaller. So there's a larger positive charge in the middle, there's a larger negative charge outside, and which is a higher attraction, which means they're going to come just a little bit closer. Excuse me. This is essentially what our atomic radius looks like across the periodic table. Cesium happens to be one of the biggest elements on the periodic table, and fluorine and helium happen to be two of the smallest. Take a look at this. Pause and take a look at this if it helps you understand it a little bit better. As we move across, elements get smaller, and as we move down, elements get bigger. So go ahead and summarize that for me. Take a few seconds. And when you've finished, I want you to give a few of these a shot. I want you to tell me whether each of these is true or false. I'm going to put up some statements, decide whether you agree or disagree. Give it a shot. Tell me if you disagree or agree. And I hope, grade yourself on your learning targets, and I hope this helped. Take care.